Hey everyone, we're back at the whiteboard and we're going to keep talking about blockchain. I don't know if you heard, but one of the blockchain networks, the cryptocurrencies, got hacked. And basically, the way that happened is that someone was able to change enough of the blockchain so that the proof of work algorithm, when it went through, it thought that everything was okay because all of the chains had been changed before it managed to get through that. So goes to show that blockchain, in some sense, is not 100% secure if it's implemented in the way that at least that cryptocurrency was. There are ways to make it more secure, but you need higher bandwidth for that. You need bigger entities, and this blockchain was actually run by a rather small entity. So in any case, in these video series, we're not really concerned about blockchain currencies or cryptocurrencies. What we're concerned about is the supply chain and the way blockchain affects the supply chain. And so we're going to keep talking about that. And one of the big announcements with blockchain is that Walmart will require the suppliers of food to send blocks or send information about the traceability of the food to IBM. And IBM has a blockchain called a Food Trust, which is meant to track food all the way through the chain, from the grower all the way to the retail store. So everybody in the supply chain who's dealing with Walmart now has to get up to speed on that. And that's a big deal. And we at Enacta are already on that and communicating with IBM on setting that up, so BC will be ready. But let's talk about blockchain from a supply chain standpoint. So again, we have the blockchain here. So we got these links. And let's say these are 3 blocks, and they're connected together like we described in last video. And so each one of these blocks has some information. In this case, I'm just going to say that here we have a shipment of item, let's say it's coffee beans. And it's 100 pounds at $10,000. So it's a sale. It's a sales shipment from a company to a customer, and it's now being shipped out. So let's say this is company A. That sends it out, right? And then the next block in the chain contains company B, and this is a receipt of the coffee beans, and they receive 100 pounds, and they know it's going to cost $10,000. So it's keep it like that. So let's say this happened. What is it now? It's 1/8, and today we got the receipt. So it was sent yesterday, today it was received, right? So now we have a ledger in the blockchain. The company A reported that they shipped the coffee beans 100 pounds, and we can, just for traceability purposes, we can say that this was lot ABC 551. And so the lot comes here, lot ABC 551, right? So the lot keeps. So you can then basically query the blockchain for the lot number, and you can see all the ledger for that particular lot, wherever it traveled, even all the way to the farm. So that's the idea behind the traceability. Now, so this is basically just a database logging the transactions, right? And so it's a centralized authority that keeps the database, and we're sending it there. And we're accepting that centralized authority as a holder of all movement for this data. Great. So why is this so important? What is so interesting about this? Well, there are more things you can do. So let's say, for example, that this blockchain had, and I would just do it like this, had contracts or smart contracts, right? And one of the smart contracts in this was that when there is a receipt, then trigger payment. So what you could set up basically is that the blockchain is listening for a receipt of product. And whenever there's a receipt of product, it will automatically release payment back. And this is really interesting if you're talking about cryptocurrencies, because that could actually happen with a blockchain as well, using Bitcoin. But it could also happen with a bank transfer. I don't see why that wouldn't be reasonable. So basically, when this happens, the next transaction here, which could happen automatically, would be from company B, send payment of $10,000. And this happens automatically. So right away, when they transfer the block, receive coffee beans to the blockchain, automatically payment is sent out to pay for that immediately. So there's no system transaction that does that. It's just all happening on the blockchain. And that's, of course, revolutionary, especially for supply chain. And again, people have to trust this. The proof of work algorithm has to be great, which it wasn't for that other blockchain. So smart contracts will definitely change the way things operate in the supply chain if we ever get around to applying them everywhere. So we're going to keep this for this video and kind of think about smart contracts. Oh, and one more thing I wanted to add to this. We have smart contracts. In order to know that this happened, there needs to be an oracle that's monitoring this. And it's called an oracle. So we'll put that here, oracle. So that is a facility that's watching the blockchain. It's observing the blockchain and executing the smart contract on the trigger. So the smart contract basically is looking at an oracle, and the oracle is telling, okay, we have this happening. This happened, or basically it looks at that, and then it triggers this. So if this happened, then it triggers this, and that gets created. So it's important to have oracles in this scenario, because if we only had the blockchain is technically just dumb storage of data, which is very secure and distributed. But as far as if you have smart contracts and an oracle, you will basically create a system. So on that note, maybe next time we go in ScreenShare and go actually into Azure and do a blockchain, create a blockchain, and use Business Central with that blockchain. Hopefully next week. Keep watching.